So today, talking about sun protection and what different things we can use for that and why it's important. So yesterday, for anybody who missed it, we've got the talk up on the website now, but we're talking through sailing gear that we use for protection from being wet and being cold. So the big ones like the wetsuit and the dry suit, and then boots and gloves and how we take care of them and all that sort of stuff. So check that out if you didn't see it. But going into sun protection, so obviously first thing is sunscreen. So let's talk a little bit about why this is an issue. Why do we need to pay attention to this? So when we've got the sun and it's sending out light and heat, but it turns out that visible light isn't the only thing that's coming down to us. So if I can actually find, let me pull that page up again. This guy. I'm going to screen share something real quick. So just to take a look at it, here is what's called the electromagnetic spectrum. Depending on what science classes you've taken, it's probably likely you've at least seen this before. But the electromagnetic spectrum is just all the different, it's just different energy levels of little photons, basically. So you have radio waves, like when you listen to the music in your car or whatever. There's microwaves. There's infrared. The visible light is actually a little tiny part of the electromagnetic spectrum. And then you go up and you have ultraviolet light, and then X-rays and gamma rays. It's all just different amounts of energy, basically. So that's in the theoretical level of things. That's the only difference between all of these. Radio is the same as light. It's just different amounts of energy. So this is what our eyes are able to see. And for some animals, like insects can see in kind of the UV range as well. So like this to them would be visible light as well. But for us, obviously, we can see the rainbow. But one of the thing that we're trying to protect ourselves against using sunscreen is that the sun is not only giving us visible light, it's also sending ultraviolet light. And it turns out the atmosphere does a pretty good job of blocking a lot of UV light. I think if we scroll down here, they had another little graph we can look at. Oh, Johnny is here. Let's admit Johnny. We've got the visible light comes through all the way to the ground. Radio waves are able to get to the atmosphere, and the atmosphere blocks a lot of UV light, but some of it still gets through. And that's the part that is kind of harmful in certain ways. So we'll talk about what that actually does. So yeah, I just thought that was kind of cool to show. So this is what we're looking at. This is what we're protecting ourselves from with sunscreen. So there's two different types of ultraviolet light that we're concerned about. They're called UVA and UVB, or long range and short range. Or sorry, not range, wave. Long wave is UVA, short wave is UVB. They do different things to us. The UVB, that's the stuff that causes skin cancer. So it's obviously not like a X-Men sort of thing where it hits you and immediately you got cancer. What happens is it's kind of damaging your skin cells, and then over time the damage that's caused is what leads to that skin cancer. So we're trying to prevent that damage from happening. The UVA is it is tied a little bit to that sort of thing. But the UVA is more going to cause just premature skin aging. So when you see the those guys that have been out on ships their whole life, and they come back and their skin is just kind of cracked and leathery and stuff, and that's kind of the extreme example of it. But if you ever seen that, like on the sunscreen bottles, it says UVA/UVB protection. That's kind of the difference between those two things. They're both causing damage to our skin, but it's different things. But we obviously want to reduce any of that damage as much as we can. So UVA, UVB, when we're looking for sunscreen, we want to find something that is talking about UVA/UVB protection, or broad spectrum protection is also how you'll see it. But that's something that it's important to look for when you're picking some sunscreen to get. We'll talk a little bit in later about other things we can think of for sunscreen. Other fun fact: don't ever go to tanning salons. It's just UV light. It's UVA. It gets you that tan, but it's also that UVA rays that we just said we don't like because it ages our skin. So we don't want that to happen. So just tans in general is not the best thing, not the best deal. So that's kind of what is going on. That's why we care. That's why we don't want those sunburns. The UVB, I guess, is kind of what gives you the sunburn as well. So it's technically not really a heat burn, right? It's almost more of like a chemical burn, I guess. Like the sun is warm, but it's not hot to the point that like we burn ourselves the way we get burnt if we touch a hot stove or something. So it's slightly different. It's not technically like getting burned by heat. So when we are looking at sunscreen, the other thing that you'll see on the bottle, besides the UVA, UVB stuff, is probably the big number in the middle, the SPF, the sun protection factor. And so that's basically supposed to be the amount of time, I guess the ratio maybe, of time that you can spend in the sun before you get sunburned compared to not wearing sunscreen. So if I had sunscreen that's 30 SPF, then in theory, I can stay out in the sun for 30 times longer than I could if I didn't have that sunscreen on. The caveat being that a lot of this types of sunscreen, especially if we're in the water, jumping in and out of the water, maybe rubbing our face with a towel, that sort of thing, it's going to kind of wear off. And so it's going to wear off a lot quicker than 30 times longer than it would take us to get sunburned. So there's something called the UV ray index that I guess the Weather Service figures out. And you can go and look up for your area what's the UV ray index. They have like 0 to 15, with 15 is the highest, but it's basically kind of gives you an idea of like how long you can be out in the sun in the general area you live before you would get sunburned. So in our area, in kind of around Maryland, in that general like geographical area, our UV ray index is around 5. And if we look that up on the scale of 0 to 15, it says we can be out in the sun for probably around 30 minutes before you really start getting sunburned. So that's kind of gives you a general idea there. It's like, in theory, if we had SPF 15, then whatever 30 times 15 is, 450, we could, in theory, be out in the sun for 450 minutes with SPF 15 sunscreen on. Like we said, it's going to wear off a lot sooner than that. So technically, we can't be out in the sun for 450 minutes, whatever amount of hours that is, like 7.5 hours, something. So that brings up another good point, is that when you're trying to pick what SPF do you need to go out on the water, the higher numbers aren't always necessarily necessary, because we know that the sunscreen is wearing off over time. So an SPF of 100 is definitely going to be more protective, but it might not ever be super relevant, because it's probably going to wear off. It's going to wear off at the same rate at which SPF 30 would wear off, and so you're not really getting too much more of a benefit from having that higher number. There's still going to be something, but if that SPF 100 is like $30 for a little tiny bottle, it's probably we could probably just reapply our sunscreen every 2 hours, and we're really getting the same protection. So on that, it was kind of interesting to look at like how that actually works. What is, as you go up in SPF from 30 to 50 to 70, what's like, what do we actually need? What's the minimum that we should get? And so if we look at it, it's maybe easiest if I kind of draw a little bit here real quick. So if we were to draw a graph of how this SPF stuff works, where's my markers? If we kind of draw up a graph here, and on this side we have the amount of UV rays that are blocked. UV blocked on the y-axis. We're getting a whole math lesson in here. It'll be cool. And then on the x-axis we have SPF. So maybe we have 15 down here, and then 30 here, and then 50 and 70. So if we have SPF, what is it, 15, that blocks, SPF 15 is going to block about 93% of all the UV rays that are coming down. So I don't know where that is, somewhere around here. We'll just say randomly. SPF 30, now you're up to about 97% of all UV rays blocked. SPF 50, you're up to like 98%. SPF 70, about 99%, and it's going to keep going like that. This is an exponential curve, and so if that doesn't make sense, why would the change be like this when this is kind of linear, right? We go an extra 20 SPF, an extra 20 SPF. Why is it only these couple of percents? Because when we're talking about this sort of thing, we're thinking more. We kind of want to turn the thinking around and call it how much UV rays are we still allowing in, right? So if we are blocking 97% of all the UV rays, that means 3% of them are getting in. So we'll just pretend that there are 100, just for the ease of thinking through this, we'll say there were 100 UV rays that were going to hit our skin. So if we block 97% of them, that means 3% are left, and 3% of 100 is 3. So easy to think of it that way. Once you get to 98%, we've blocked 98 of them, so there's only 2 coming in, right? Once we block 99, there's only 1 coming in. So the big numbers, the 97 and 98, are kind of weird to think about when we're looking at these jumps down here, jumps in SPF. When we think about it of this, oh, we're blocking another percent and then another percent. Now we're blocking like a third of everything that's coming in. Now we're blocking closer to a half, like a half to a third. These numbers aren't going to be exactly exact, right? And then maybe if we go up to 90, it's like 99.5 or something. And so now we're blocking another 50% of all the rays coming in. So when we think of it that way, it's a little easier to understand. And if my explanation didn't make sense, that's okay. We don't really have to have a full understanding of that exponential curve and everything to just know that when we go up to higher and higher SPF, it does block more, technically blocks more sun, but the point where we'd see that happening is we're probably going to be reapplying sunscreen beforehand anyway. So the long story short with that is, if you're going out on the water, you're trying to figure out what SPF you need. If you get SPF 30 and are applying it, to the right amount of thickness, we're not just taking like a little tiny dab and smearing it everywhere. We're getting a good amount rubbed into our skin, rubbed into our face, our hands, everything that's exposed, and then we're reapplying it when it's wearing off. So for stuff like when we're doing sailing, it's basically if you put it on at the beginning of the day and then reapply at lunch, that probably covers you, as long as you got a good coat on. So reapply twice a day. If we're like swimming in the water all day, it's going to wear off faster. But just sitting in the boat and maybe occasionally we capsize and go in the water. Reapplying a good amount twice a day is going to cover you. So if we're doing that, we're getting that good covering, and we are reapplying when we need it, then SPF 30 is going to do what we need. So that's kind of that's typically like the most common number you see anyway. So basically, most sunscreens that you find are going to do what you need them to. And certainly you will get some more protection as you go further up in the scale. But as we said, it is a little bit of diminishing returns when you're factoring in how much it's taken away, and the fact that often the price is going up at this kind of scale instead of this kind of scale, and the fact that it is wearing off throughout the day. So bottom line, you find that broad spectrum or UVA/UVB protection and at least SPF 30, and that'll cover you for sunscreen. Another thing you can look at is try to find something that says something about sport or waterproof, because that will just give you a little bit extra protection against it running off. The sport stuff, they often say is it's going to be like less runny coming out of the bottle. And that just helps it not, when you're sweating or you're getting some water on your skin, just helps it not to wash off quite as much. So that's what I usually look for as well, is something with it says either sport or waterproof, and typically that is a bit thicker, like a paste rather than like almost a liquid, as some of them are. So it just helps it not to wear off as fast. So yeah, I guess three things you can look for in sunscreen there. So cool. That is sunscreen. We got to make sure that we're protecting our skin. One other part about the sunscreen that I almost forgot about. So there's also different kinds of ingredients in your sunscreen. You can have either a chemical blocker, they call it, or mineral blockers, or physical blockers. They're sometimes called mineral or physical versus chemical. So chemical sunscreens are the typical ones that probably most of you would use, and there's a bunch of different possible active ingredients that are like weird chemical names that I won't try to read for us. But basically they're the stuff that you rub on and it kind of soaks into your skin. And then that's the way that's blocking it, is it's actually it's either like soaking up or absorbing those UV rays. So they're preventing those UV rays from actually doing anything to your skin cells. A physical blocker, the two main ones you'll really see are either zinc oxide or titanium dioxide. And those don't soak into your skin. They kind of stay on top of your skin. So if you've ever seen those photos of like the professional sailors and they have like the white streaks on their face, that's what that is. It's either the zinc or the titanium stuff. And it's that stuff it's always kind of a paste, and it rubs in, and it really doesn't wear off. I mean, it will, but it takes a lot longer to wear off than the chemical stuff. So that's the sunscreen that I use. I kind of go back and forth between, I'll have like a really good like sport sunscreen that's decently thick, and then I've also got a tube of the zinc oxide stuff. And I will tell you, I've never ever gotten a burn with that zinc stuff. The one issue I do have with it is that because it is sort of a paste, it doesn't soak in. It's really annoying to clean off later on. Like you have to have like a washcloth or something, or you're just sitting like scraping at your face trying to get all this stuff off in the shower. But it is, for what it's supposed to do, it does it really well. It keeps you from getting sunburned. So as long as you have a good sunscreen, one or the other, I don't think there is any particular benefit to mineral. It's not going to be better at keeping you from getting sunburned. It is two different options. So yeah, that's the last bit about sunscreen. Now, when we're talking about protecting our skin from the sun, there's other possibilities too, because we could either cover our skin with sunscreen or we could cover our skin with clothing. And several of you have heard my not rant about this before, but my long-winded discussion about how tech tees, our long sleeve tech tees, are just the greatest thing in the summer because they do cover, they cover your arms. If you have the ones with the little hood, they cover the back of your neck too. And so it's just that much less of your skin that you have to worry about, keeping covered with sunscreen and reapplying. So you don't use as much sunscreen because when I'm out, I'm really just covering my hands and my face and like the lower part of my legs. So kind of the more you can cover up, the better, especially if when we're talking the summer and we're out on the water all day. For high school sailing, it's maybe not mattering quite as much because we're out practicing for maybe 2 hours, or when we go to a regatta on the weekend, then we're outside all day. So we definitely need to be paying a little more attention, especially when you're out in the middle of the day. I think, what is it, like 10 a.m. to 2 p.m. Those kind of 4 hours in the middle of the day. That's when you're going to have the most amount of intensity from those sun rays. So that's kind of the peak point. And then by the time you get to the afternoon, you don't have quite as much UV rays coming down to you anyway, as you did in the middle of the day. So between the smaller amount of time and the less intensity, usually the afternoons are not quite as bad. But certainly when we're out all day for either a regatta during high school season, or if we're out sailing during the summer, especially, if we're spending all day on the water and we're never going inside, that's when we really need to pay attention, make sure we're getting that reapply if we need to, and certainly having those long sleeve shirts, just a little more of your body that you don't have to worry about. And if you got the right kind of clothing, we're not saying go out there in a black cotton shirt, right? We got those little swishy fabrics, whatever they're made of, that are the kind of stretchy, swishy stuff, those tech tees. So technically, yes, you're going to be a little bit warmer because you don't have the breeze over your arms, but in my opinion, it's definitely worth it to make sure that we're getting that basically 100% protection from the sun. If last summer, it was interesting to like see the coaches out on the water, especially the ones that are like the guys that come up from Argentina or wherever, and like this is their job, that's their career. They're out on the water all day, every day, like most of the year, and they're like, you can't see their skin. They have like buffs over their face and low hats and the hoodie shirt, so you don't see the back of their neck. And they even put on like the little like leg sleeves and everything. Like you literally don't see an inch of skin besides their hands, because they understand, the more time you're in the sun, the more time it's those UV rays are hitting you, even if you got the sunscreen on. So yeah, sunscreen and clothing, between the two of those, we can get pretty good coverage, keep us pretty safe. But there is one part that no matter what we do with clothes and sunscreen, we're not covering, and that's our eyes. All right. So another one of my maybe more long-winded discussions that we have heard before is the deal about polarized sunglasses. So let's talk a little bit about that and what that can do for us. So we've already mentioned, right? We've got these UV rays coming down, and they do different things. They do bad things to our skin. They do different bad things to our eyes, right? So there's 10-minute warning there. The UV rays in the sunlight, they can cause cataracts. They can cause something called corneal sunburn, which is, if you know the different parts of your eye, your cornea is off the top of my head. I don't remember exactly what it does, It's not it's like the covering, the front of the front kind of covering of your eye. Correct me if I'm wrong, but at any rate, that can get sunburned, and that's if you've ever heard of snow blindness, it's literally like your eye getting sunburned and light can't get through. So like bad cases, like people that go and climb mountains like Everest, if they don't wear dark goggles, they'll get that in. And like the extreme cases are they're literally like completely blind for a couple days until that recovers. So it is highly unlikely that you get something that bad, but certainly your eyes can be really irritated spending a whole day out in the sun. So there are definite bad things that can happen if we don't protect the eyes as well. So when we talk about sunglasses, there's obviously different kinds of sunglasses. A lot of us just wear the little like $2 things that are basically just kind of darkly shaded plastic lenses. And then if we talk about polarized sunglasses, let's look at how that works. So if I get my eraser here. All right, so when we have sunlight, or really any light source, right? It's kind of light is a big wave. So it kind of, if we look at it from the side, it's going back and forth like this. If we look at it from the top, we can think of it like a big sheet of paper, right? If this sheet of paper, if I were to take it and curl it like that, that's what we're seeing from the side, right? It's following that wave. But looking at it from the top, it's like that. But it's not just one direction like that. It's this direction, or it's this direction coming to you, but it's also that direction and that direction and that direction and that direction. It goes through a full circle. So what polarization does is it's basically like a gate. So there's something in a polarizing filter. There's a bunch of line. There's a bunch of it's like a grid. It's too small for us to see, but if we were to blow it up and magnify it, that's what's going on. And so all these light waves that are coming in at this angle can't get through, and this angle and that angle and that angle, they all can't get through. Only the ones that are going in the same direction as the grid can get through. So that's what's happening with the polarizing filter in your sunglasses, is it's blocking a bunch of light. It's only letting in the light waves that are going this direction, right? All the same, the same colors and everything are all getting through. It's just that only a small amount of the original light is getting through. So that'll make things a little darker. But the other important part with those polarizing sunglasses, it's not only filtering out a whole bunch of that light, which is not just the visible light, but also the UV rays. So it's getting rid of all those UV rays for us. It also cuts glare. And so if anybody's ever been kind of looking into the sun, in the sun's direction, looking at the water towards, like facing toward the sun, you get all that kind of that glare, all those sparkles that are coming into your eyes, and it just makes you squint up your eyes, and it's horrible, right? But the way polarizing sunglasses cut that is if we were to blow up our sunglasses, this is what it looks like. This grid is vertical. The light glinting off the water, it's bouncing off a horizontal surface. So the glare is made up entirely of horizontal light, right? So that's one, since it's not coming straight from the source, it's bounced off the water, and it only had one angle to bounce off at. All the rest of it did go into the water. So it's coming in horizontally, and what did we just say? This is going to get blocked by the polarizing filter, right? So that's how those polarized lenses are going to cut the glare on the water, which for even just that, I would say is a big reason why it's worth it to have the polarized sunglasses. But then it's cutting out a lot of those UV rays as well. So you can almost think of it as sunscreen for our eyes. Fun fact, I don't know if you'll be able to see this. Let me see if we can do that. Um, the like digital things like a phone or a tablet, usually that light is polarized as well. So let's see if we can actually see this. I've got my polarized sunglasses looking at my phone screen. If I can figure out how to move my phone backwards in the camera, there we go. So if I turn the phone, see how the image is kind of getting darker? Or if I turn the glasses, see how the image gets darker? Because this light is polarized as well. So it's coming out at mostly one angle. And so when we turn it sideways, it's getting blocked by that polarizing filter. So obviously we could see it didn't completely block everything. So it's not 100% polarized, but it is mostly. It's just kind of how the digital screen works. I don't know exactly how that's all built and put together and given out light. So if you're looking to find out if a certain pair of sunglasses is polarized, you can take another pair, and I only have one pair of polarized sunglasses. This is the only pair of sunglasses I have, actually. Otherwise, I would show what doesn't work. But you can take two sunglasses and face them toward each other, and then turn them at a right angle. And if they're both polarized, like we just said there, every pair of polarized sunglasses is going to have a vertical grid like this. So if they're both polarized, then the two grids are going to go from being, when we turn them 90 degrees, they'll go from being like that to like that. And so neither one of them lets light through, and it actually goes like completely black right in that spot where the two lenses are, where you're looking through the two lenses. It's kind of cool to see, actually, because it's like, it's not something you would really expect to happen. But so that's how you can kind of test if you have a pair of sunglasses that you don't know are they polarized or not. Find a pair that you do know is polarized, and then just turn them 90 degrees to each other, looking into each other, and you can find out that way. So another thing, I know a lot of people don't like to get polarized sunglasses because they're worried. They're like, that's a more expensive pair of sunglasses, and what if I lose them? Kind of using they're using my sailing glove idea, or Curtis's sailing glove idea of you just get the cheap gloves, $3 a pair, and they'll wear out in a season, and I'll spend another $3 on them next season. And so they kind of take that same idea for the sunglasses. And so kind of a couple thoughts as to how we could fix that is, one, you don't have to, polarized sunglasses are not, they don't have to be the super expensive ones. You don't have to spend $150. I just checked on Amazon right before we got on Zoom here, and found a pair of polarized sunglasses for like $20 that had 4 stars. So they can't be horrible. Certainly they're going to be at least as good as the $2 ones that we get. And so, if you're worried about them falling in the water, we can get those little croquis, little straps. But once you try those polarized sunglasses, they are just so nice. They fix up the vision so much. They're cutting through that glare.